just a second.
Okay. In the meantime, I just wanted to talk a little bit about something called the inner and the outer function or functions. So let's analyze this. We're asked to find the limit of this, right? What do we have to do first when we're asked to find a limit? And yes, 99% of the cases. If it has a radical, then I have to find the domain. If it's absolute value, then I have to simplify it. But most of the time, what do I have to do first?
Plug it in.
Yes. So now let's take a look. I have a function, which is the exponential with base e, raised to another function. This is a function, and e to this is another function. Which of these two is the inner, and which one is the outer? Maybe we should start with an even simpler example. If I have natural log of x cubed plus 2 for this one, and then we'll come back to this. What is the inner, the function that I have to evaluate first?
The x cubed plus 2.
Of course. And then what will be the outer?
Natural log.
Natural log x, indeed. So when I'm given something like this, first I have to identify the inner. And of course, this is the inner. And then e to the x is the outer. So when I plug in to evaluate and see what's happening here, I have to plug it in the inner first, of course. So negative 3 times 4 is negative 12. Negative 12 plus 2 is negative 10. So the answer is directly 1 over e to the 10th, because e to negative 10 is 1 over e to the 10th. There is no need to do anything here. There is no need to rationalize or whatever. Nothing. It's a number. Once it is a number, you don't have to do anything. Again, the same thing here. When I'm asked to find this limit, first I will look for the inner. I will plug in infinity in the inner. When I plug in infinity in the inner, what do I get?
Infinity.
Perfect. And what is the arctangent of infinity? What does it equal to? From the graph from last time. We have to remember the graph of arctangent. Like the graph of 1 over x or e to the x or natural log. These graphs should be forever embedded in our system. Anyone? So where is arctangent going when its argument goes to infinity?
Is it 1 or 2? I can't actually tell. I graphed it.
This is an important, very important concept. You can move on without it. Especially if you need Calc 2. So what is the answer? Anyone?
Pi over 2.
Thank you. And now I think I can recycle this. Yeah, I can. Good, so the answer is indeed pi over 2. Yes, we have a WebAssign question. Thank you so much for bringing it to class, because I said everyone will benefit from it, but now I forgot what it was. So if you, yes, I'm ready.
Okay, so I have it. I want to read the question.
Oh, I remember. It was the square. Oh, I remember now. 5 minus x plus the square root of x squared minus 1. Got it.
No, it wasn't that.
Oh.
It's number 9 from 2.5, if anyone wanted to look it up. And the question is, find the values of a and b that make f continuous everywhere.
Oh, yes, it was a piecewise defined function. I got it. Yes,
Yes.
I'm ready.
So the first one is x squared minus 4 over x minus 2 if x is greater than 2. Second is ax squared minus bx plus 3 if 2 is less than or equal to x is less than 3. And 4x minus a plus b if x is greater than or equal to 3.
Awesome. Perfect. Now, let me just look at the time. In 2 minutes, I will not be able to finish it. You're free to leave if you want after 2 minutes. More than I can't hold you. But I will finish the problem. It's recorded. I will post it. But I only have 2 minutes left, so I will not obligate you to stay. If after 2 minutes you have to go, you have to go. But I will finish the problem because once we start it, I can't leave it like that. The other thing is that I was going to say, we do not meet on Monday and Tuesday for the holiday, and we meet again on Thursday, and we will start chapter 3 on Thursday. Okay. So, and thank you. Happy 4th. If you want to stay, please stay. If you have to go, you have to go. So, first of all, I'm looking at this problem, and I realize that I have to factor into x minus 2 and x plus 2 and divide it by x minus 2. X is not 2 anyway, so I don't have to state any restrictions, so I will simplify. So always remember factor and simplify. The two key words, we put them here a few minutes ago. So factor and simplify. Okay, so please remember that. So the first piece now becomes x plus 2 for x greater than 2. The second piece, there is nothing I can do to it. Ax squared plus bx plus 3 for this. And then 4x minus a plus b for this. Perfect. Then, yes?
Small thing, it's for the x plus 2, it's x less than 2, not greater than. I might have said that wrong.
Oh, yes, of course. No. Yes, I should have known. I should have known, of course. My fault. Of course, otherwise it will not be a function. Good. So then, in the next step, I have to write this sentence. So number one, I have to write that x plus 2 as well as ax squared plus bx plus 3 as well as 4x minus a plus b, because a and b are numbers, are continuous everywhere as Pauli functions. So that's done. In number 2, I have concern about x equals 2. So I have to study continuity and x equals 2. In step 3, I have to study continuity at x equals 3. So the limit as x approaches 2 from the left, 2 from the left from x plus 2, must equal limit as x approaches 2 from the right of ax squared plus bx plus 3, and must equal f of 2. So now when we determine this limit, we get 2 plus 2, which is 4. When we determine this limit, we get 4a plus 2b plus 3. And this is the same with this, because that's where the equal symbol is. So I already have the first equation. 4 must equal 4a plus 2b plus 3. Since I have two variables, I have to determine two equations. If I determine or get two equations. Now for x equals 3. The limit as x approaches 3 from the left, but 3 from the left is from ax squared plus bx plus 3, must equal the limit as x approaches 3 from the right from 4x minus a plus b, and must equal f of 3. That f of 3 will equal to this, so I don't have to write it again. So now let's see what we get. So this is 9a plus 3b plus 3. And this one is 12 minus a plus b. So this must equal this. So this will be equation A, and this will be equation B. Now from these two equations, I will create a system with A and B. I'm checking my numbers. Once I made an error once, I'm checking everything. So again, 9A, yes, 3B, okay, yes. So this is 12 minus A plus B. That's correct. Everything here is correct. Yes, 4, 2B, yes. Okay. But I will clean...
Sorry, the AX squared equation is minus BX. So just minus 3B. Again, it's small.
So both of them. Oh.
Yeah, I just caught it just now.
Oh,
minus BX.
Oh, here?
Yeah.
Oh, that's okay. So let me dictate this back to you. So it's x squared minus 4 over x minus 2. Is that correct?
Yes.
Then ax squared minus bx plus 3. Is that correct?
Yes.
Okay. It's good that we caught it now. So, and then again 2 and 3, right? And this is correct
Yes.
for x minus a plus b?
Yes.
Okay, good. No worries. No worries. Okay, so I just need to correct this here. And I need to correct it here. It's a squared minus bx plus c. And I need to correct it here. And I need to correct it here. And this one was okay for x minus a plus b. So I think we're okay now.
Yes.
Is that correct?
Yes.
Okay, awesome.
Yeah, sorry. Thank you.
No worries, no worries, no worries. Really, no problem. Okay, so then the first equation is 4a minus 2b plus 3 equals 4, but I have to move 3 to the other side. So 4a minus 2b equals 1. I subtract 3 from both sides. 4a minus 2b equals 1. Now here, I need to clean it up again. So I'm adding a, so 10a. I'm subtracting b, so negative 4b. And then 3 goes to the other side. 12 minus 3 is 9. I have to clean this up as much as possible and have a below a, b terms with b below b, and the free terms outside. So 4a minus 2b, subtract 3 from both sides. Positive 10a minus 4b, move 3 to the other side. 12 minus 3 is 9. At this point, I will decide to eliminate b. So I will multiply the first equation by negative 2. So I have negative 8a plus 4b equals negative 2. And then 10a minus 4b equals 9. These two go away as planned. This is 2a, and this is 7. So then a equals 7 over 2. 7 over 2 will go here. 4 times 7 over 2 is 14. 14 minus 2b equals 1. So I simplify. So 2 times 7 is 14 minus 2b equals 1. So then negative 2b will be negative 13. 1 minus 14. So then b equals 13 over 2. So we determine the two constants or parameters. We determine the two parameters that make the function continuous. And in writing, I have to rewrite the function. In WebAssign, I don't have to. So now the function that is continuous everywhere is x plus 2 for x less than 2. I replace a by 7 halves. 7 halves minus 13 halves, of course, x squared minus x plus 3 for 2 less than or equal to x less than 3. And the last one is 4x. And now here I have negative 7 halves plus 13 halves, which is 6 over 2, which is positive 3 for x greater than 3. And now this is guaranteed. F of x is continuous on negative infinity to infinity. So we had to go through these steps. We had to state the definition of continuity at these 2 points. We had to set everything equal to each other. We had to create a clean, simplified system of 2 linear equations in 2 variables. We used elimination by multiplying both sides here by -2, -8 plus 4b minus 2, and so on and so forth. At this point, I have to take a moment and plug them in. What point? I have to plug in 7/2, comma, 13/2 to make sure that both equations work. If this does not work in one of them or something is wrong, then this is not the correct solution. So I have to take a moment and do that. So I have here to replace by 7/2, 13/2, 13/2, and 7/2. Okay. So this is indeed 14 minus 13 is 1. Check. This one is 5, so 35. And this is 26. 25 minus 26 is indeed 35 minus 26 is indeed 9. So now I know that this is for sure the correct solution. I don't need anyone to tell me whether it's correct or not. I checked. It is. And in writing, again, I have to put them in. I have to put them in because the problem will ask me to create the function, not just determine a and b, but of course this is not a problem for a test situation only because it's time consuming, right? So you have to set it up and so on and so forth. It's not for really for a test situation because of all these steps. But it's not a difficult problem. It has more algebra in it than calculus. From the moment you establish the two equations, the rest is just algebra. I'm very happy that you brought this to our attention so I can show it in class for everyone.
Yeah, thank you. I'll watch that again. I think I messed up a couple different steps in there.
But is it clear? The steps are clear.